a little while ago we looked at this function, the inverse sine of 1/2. The thing to keep in mind about your inverse trig functions is that they're going to give you an angle. Now in this case it's the angle whose sine is 1/2, so that means sine of theta is 1/2. Okay. Sine is which coordinate on the unit circle? It's the y coordinate. So what you're being told here, what you're trying to find is theta, so that the y coordinate is 1/2. And for some of you, that's a more and more familiar point. The coordinates there are square root of 3/2 and 1/2. And where does that happen? What angle? 30 degrees. But keep in mind, that's not the only place where the sine is 1/2. Where's the other place where the sine is 1/2? On the other side of the unit circle here, right? Right over here. Well, so that's negative root 3/2 and 1/2. So both of these are places where you could say, well, look, hey, the sine is 1/2, right? So how come when your calculator does the inverse sine and you're in degrees, you get 30 degrees and not 150? How come when I do the inverse sine I get 30 degrees and not 150? Or let's put it this way, how come I get pi over 6 and not 5 pi over 6? Well, the reason goes back to the range, right? Remember the range of the inverse sine goes from negative pi over 2 to pi over 2, or from negative 90 to 90. 150, or 5 pi over 6, is outside of that range. So we don't have to worry about that, at least right now, when we're dealing with the inverse sine. We only have the one solution. We have exactly one solution, because anything else wouldn't be in the range of negative pi over 2 to pi over 2, or negative 90 to 90. Okay, so let's look a little bit closer at this business with domain and range, because there's some interesting things that happen. So in front of you, you have a handout. And let's just verify something by calculation. And for this, it actually doesn't matter if your calculator is in degree mode or radian mode. But when you're going to calculate this, one way to do it is to start from the inside out. With your graphing calculators, the cool thing is that you can do it all in one go. So let's type in the sine of the sine inverse of negative 1/2 and see what we get. So the sine of the sine inverse of negative 1/2. Did we get anywhere? Yeah, you got negative 0.5. But that's where we started, right? We started out with negative 1/2, and we ended up with negative 1/2. You can see that very clearly if you do the answer to fraction key trick. So, okay, that's not a real big surprise. What I told you earlier is that the sine, a function and its inverse, when you do one then the other, gets you back to where you started from. So, not a big surprise in that regard. Let's keep going. Let's try a different one. Let's try the cosine of the cosine inverse of negative root 3/2. So cosine of the cosine inverse of negative of root 3/2. And it might not be terribly clear here, but that number is negative root 3/2. You can verify that just by calculating it and comparing it. So again, you're not really getting anywhere. Function and the inverse cancel each other out. Am I going to see a different result with the tangent or with the sine or with any of these. No, you're always going to kind of get back to where you started here. And there's kind of a nice general thing happening here. And that general thing is this. When you do the inverse function and then the function on the outside, you're always going to end up back where you started from. So that works pretty nice, as long as you're doing things in this order. There's one other little catch here in order for this to work. And you can see that really quickly if you tried to take, say, the sine of the sine inverse. You know what, let's just do this. Let's just do the sine inverse of 2. What happens to you when you do the sine inverse of 2? What's your calculator telling you? Error. Does it tell you what kind of error you made? It's a domain error. That's right. Because what do you think about what you're looking for? If you're trying to find the sine inverse of 2, you're looking for something that has a y-coordinate of 2 on the unit circle. There isn't anything. Y-coordinate of 2 is way up here. You're not going to find that on the unit circle. So when you do this, you get an error. Not surprisingly. So the only time that this nice little relationship won't work is if x is not in the domain of your inverse sine function. The domain of inverse sine and inverse cosine is negative 1 to 1. So that's the only time it's not going to work. Let's reverse the order here. Let's see what happens when we do that. So let me maybe do this. Let's see, do you want to do this in degrees? Should we do this in,
What's the easiest?
I think it'd probably be easiest to see in degrees. Does anyone know what pi over 6 is in degrees? 30. So translating this to degrees, it'd be the sine inverse of the sine of 30. Make sure your calculator is in degree mode. And let's see what we get when we do that. 30. Shock. All right. So you get 30. And what I have on the handout is the same thing except in radians.
Do you want it? Will you specify if you want it in radians or degree?
Mostly we'll probably be working in radians. But I want to do a couple. Yeah, I'll specify what I want. I want to do a couple more here. Let's skip down to this one. Sine inverse of the sine of 5 pi over 6. Now 5 pi over 6 is 150 degrees. So let's do the same kind of thing for 150 degrees. In fact, here's a quick trick for you. Hit the second key, then the enter key. And what's it do for you? Pulls up your previous calculation. Let's just go over here and type in 150. Now, in our previous one, I ended up back where I started. Not so much in this case. So, hate when that happens. Not everything is aligning quite right. This one didn't work out. This one did. Why didn't the second one work out? Excellent. If you take a look at 150 degrees, it's not within the range of the inverse sine. Inverse sine is going to give you angles between negative 90 and 90 degrees, or negative pi over 2 to pi over 2. So when you look at an angle like this, there's no way the inverse sine can give you an angle or the same angle back because it's not in the range. It's not in either of these. So for this one, we get back to pi over 6.
Jeff, why the calculator earlier when you punched in 2 gave you a better domain, but now is it like kind of like programmed or no?
Well,
is 30?
I got a domain error earlier because there is no angle with a y coordinate at 2. So that there's no inverse sine of 2. The inverse sine only takes values between -1 and 1.
Correct.
So that's why I got that. Now, I didn't get an error here, did I? I just got a different number than what I started out with. I started out with the 1.
Why don't you get an error since it's outside of the range?
No, because what's going to happen here? Let's take a look here. When you take the sine of 150, the sine function is going to give you a number between -1 and 1, always. And the inverse sine has its domain, the values between -1 and 1. So we're okay. You just didn't happen to end up where you started, that's all. So it's a good question, but there's nothing that's going to be undefined about this. Because when you take the sine, you're automatically going to get a number between -1 and 1.
So will you always give us a number that's paired with a function on the unit circle?
I'll tend to favor these kinds of values that are special points on the unit circle, but we don't have to go there. Just what I want you to get to is the conclusion here. So let's do one more here, and let's do it in radians this time. We'll do the first part of it kind of by hand here. Sine of 4 pi over 3. Well, 4 pi over 3 is a special angle on your unit circle. It's 240 degrees. So you look at 240 degrees. That's down here on your unit circle. (240 degrees) has coordinates of -1/2 and -square root of 3 over 2. So there's your 240 degree angle. What's the sine of that going to be? -square root of 3 over 2. So let's put that in here. -square root of 3 over 2. So Mod, this is what you were asking about earlier. When you take the sine of this, now you've got something between -1 and 1. When you take the inverse sine, it's going to be well defined. Now, the inverse sine is going to give you an angle between -pi over 2 and pi over 2. Yeah, that's a good way to do it. So what I want is an angle in this interval whose y-coordinate is -√3 over 2. You don't have to have these memorized anymore, especially now that you understand a little bit about the inverse sine. If you do the second button, inverse sine of -√3 over 2, 3 divided by 2, I get -60. So that's telling me this angle down here, -60, -60 or +300. I think we went through this before. Let's keep it at -60 because the inverse sine is going to have as its range -pi over 2 to pi over 2, or in degrees, -90 to 90. -60 falls in that range. Just convert that to degrees, or excuse me, convert that to radians, it's going to be -pi over 3. So when you line things up this way, the inverse function on the outside, the function on the inside, they don't always nice and neatly cancel. The first two did, the second two didn't. And I think it was Keith said it really nice. When does this happen? When do these things cancel? When this value is in the range of the inverse sine. So same thing with the inverse cosine, but these two things are going to cancel each other out perfectly if this number is in the range of negative pi over 2 to pi over 2. Go ahead. Doesn't matter what x is relative to the domain of sine or cosine, because sine and cosine are defined for everything. So we don't have to worry about the domain of the sine function or the domain of the cosine function. We just have to worry about, does this fit into the range of this inverse function? That's when it's going to work. So that's the big conclusion on this. And it's taken us a while to get here, so I'll pause for a second. If you'd like to follow up with some more thoughts, or we'll do one or two here from the book. Okay, great case out in the audience. Let's take a look at a couple in the book, starting with problem number 38. It's on page 192.
This is all the same.
Same stuff. Sine inverse of the sine of negative pi over 10. How would that simplify? Am I going to get the nice simplification that I hope, or not? Let's understand what you should be looking at. You should think about the range of the inverse sine. Is that number in the range of the inverse sine? What was the range of the inverse sine? So negative pi over 2 to pi over 2. Does negative pi over 10 fit in here? Actually, it does. Yeah. So negative pi, that's like an 18-degree angle. So that would fit nicely between negative 90 and 90. Maybe it would be easier to see. Let me try to think here. If we got a common denominator. So instead of negative pi over 2 to pi over 2, what if I made the denominator here 10? It'd be negative 5 pi over 10 to 5 pi over 10. Is it a little easier to see now that this is in between these two?
So if it has a common denominator.
I just did that to hopefully give you an easier way to see that this fits between here. You could convert that to degrees. It'd be negative 18 degrees. Negative 18 is definitely between negative 90 and 90.
How do you figure that out?
No, it's just like usual. You multiply by pi over 180, or 180 over pi. So negative pi over 10 times 180 over pi. You get some nice cancellation. Pi's disappear. 10 goes into 180 18 times. So negative 18 degrees. Okay. Yeah, you just need to understand it one way. You don't have to understand it both ways. So whichever way works. Because this is in the range here of the inverse sine, what's my answer for this one? Negative pi over 10. Yes.
Is that always the range just for sine? Or
That's the range for sine.
And the cosine is going to be like what we did on here too. It's going to be between -1 and 1.
The,
I'm
Yeah. For the cosine, it's 0 to pi. For the sine, it's negative pi over 2 to pi over 2. Yeah. Thank you.
Like you said, 0 to pi for cosine and
0 to pi for cosine, and negative pi over 2 to pi over 2 for...
we just okay.
All right.
So that's 0 to 1.
Let's try number 40. Sine inverse of the sine of negative 3 pi over 7. This one, if you're a fan of the degree method, it's not going to convert to something nice and easy, but you should be able to tell if it's going to be between negative 90 and 90. I mean, that'll be clear. So, in fact, let's do that together. I'm going to multiply this by 180, it's going to be pi over 180. No, other way around, 180 over pi. Negative 3 pi over 7 times 180 over pi. No nice cancellation here other than the pi. That's all right. I'll get negative 540 over 7. And I'll take out a calculator. 540 divided by 7, 77. So it's about a negative 77 degree angle.
So then the answer would just be negative 3 pi over 7.
Exactly. Since this falls in the range, then the answer is simply negative 3 pi over 7.
So we're pretty much just checking that it's falling.
You're checking to make sure that this number is in this range. By kind of a similar example, let's see. Let's do the cosine inverse of the cosine of, well, we'll do 3 pi over 7. So positive 3 pi over 7. I know from just a minute ago that that's a 77 degree angle. 77 degree angle is in 0 to 180. So these two are going to cancel each other out very nicely. All right. There's one other thing that I'd like to do from this section. I'm not going to take the time to do it today, although it's a cool formula. And it relies on the inverse cosine function. It's for calculating the number of hours of daylight in the day. So if you take a look at it, it involves the inverse cosine, the tangent, and tangent of a product of two things. It's a little bit tricky to work with. If I want you to work with this, I would practice it in class and also give you a definition of this. This is not something that I would expect you to memorize. But for right now, let's call it a day on section 3.1. Yeah. Whew. Yeah, it's coming up. For homework, try problems 13 through 49. Want more? Sure? All right. Yeah, 13 through 49 should work pretty good. Well, the extra credit one, if I get around to it, would be a problem like 69 or something like that. But just the odd problems. I can make it the even ones if you like. You sure? All right.